We've seen what happens when we solve an absolute value equation, an absolute value inequality when the absolute value is on the lesser side of the inequality. So now let's figure out what happens if the variable part is on the greater side of the inequality. So let's solve this. Absolute value of x is greater than or equal to 4. So let's do what we did before and draw a number line. Probably 0, 4, and minus 4 are going to be important numbers, so let's mark that on our number line. And then ask, where are the numbers whose absolute value is greater than 4? Well, anything greater than 4, its absolute value is greater than 4, right? So for positive numbers, if it starts out greater than 4, it's the number that we want. So for example, 5, the absolute value of 5 is 5, and that's greater than or equal to 4. So 5 is a number that we're after, but you can see any number greater than positive 4, its absolute value is the same number, and that's greater than 4. So those are all solutions. Where else are solutions? Well, any number, what about numbers over here to the left of minus 4? Like minus 5. Well, if we stick minus 5 into our inequality, we get minus 5 absolute value of minus 5 greater than or equal to 4. Is that true? Well, yeah, because the absolute value of minus 5 is 5, and 5 is greater than or equal to 4. Right. Again, this is happening because the absolute value kind of folds the number line in half. Right. So 4 and minus 4 kind of end up in the same place after you folded it in half, and we want stuff greater than 4, and so that's all the stuff to the right of 4, but because we folded the number line in half, all the stuff that was to the left of minus 4 kind of folds over to the right of positive 4. Anyway, you can see that if a number is to the left of negative 4, when you take its absolute value, you get to the right of positive 4, and so you're bigger than positive 4. So all the numbers to the left of negative 4 are also solutions to this inequality. What about stuff between minus 4 and positive 4? Well, stuff between minus 4 and positive 4, the absolute value of all those numbers is less than 4, right? So those aren't solutions. So this graph is a picture of all the solutions to this inequality, although, because this inequality is or equal to, we should put big solid filled in dots on positive 4 and minus 4. So this is a little bit strange. We solved this inequality, absolute value of x greater than or equal to 4, and we actually got 2 chunks of the number line, not just 1 chunk. We got everything to the right of 4 and everything to the left of minus 4. So the way to write that with inequalities, so we've graphed it here, but let's also express this result in terms of inequalities and also using interval notation. The way to express this with inequalities is to write, well, x can be less than or equal to minus 4, or x can also be greater than or equal to 4. So we have to write the two inequalities separately because they're sort of describing two pieces of the number line that don't overlap, right? So we have to just write them separately. The way to write this with interval notation is, first of all, write down these two intervals in interval notation. So the one on the left starts at minus infinity and goes up to minus 4, not including minus infinity, but yes, including minus 4, so put a square bracket on minus 4. So the interval from minus infinity to minus 4. The interval on the right starts at 4 and goes up to infinity, so that's the interval from 4, infinity, including positive 4, but not including positive infinity. And now we need to come up with some way to say that both of these intervals are part of the solution that we're describing. And the way that mathematicians have come up to do that is they invented a new symbol, basically, which is this symbol that's sort of a very smooth U, or sometimes it gets called the cup symbol because it kind of looks like a cup. And the way this is pronounced union. So we would say the interval from minus infinity to minus 4, union the interval from 4 to infinity. And union just means the first piece, but also the second piece, those two pieces together. All right. So the lesson to draw from all of this is that when the absolute value of the variable part is on the greater side of the absolute value on the greater side of the inequality, the variable part is outside the negative and positive versions of the two numbers, right? So in our example, the number was 4, and x turned out to be the stuff to the left of -4 and to the right of 4. So not the stuff in between, but outside the positive and negative version of the numbers.